All right, everybody on online can see my screen and stuff.
Yep, we're all good.
Cool.
Yep.
Have you ever watched like tons of Harry Potter movies in a row and then start casting little spells around the house? It's never happened to you? Mr. Gonzalez and I did that a bunch this weekend. We were turning lights on with Lumos. Do you know you can do that with Android? Do you have an Android device? You can tell Google Assistant Lumos and it'll turn the flashlight on. It's true. You just do it. Oh man, watch this. Watch this. Lumos.
Turning flashlight on.
How do I turn it off? Oh, is it? It's Knox. I think the Knox is the light off one, right? And you guys are never going to make it in Hogwarts. I would think Gryffindor. Yeah, I would think so. I'm kind of the heroic type. I'm guessing you thought Slytherin. Ravenclaw. What's the Ravenclaw? Nobody good came from Ravenclaw, did they?
Yeah, very smart.
Really?
Yeah.
Well, it's interesting because the movies and the books don't make that like they're not the cool people. I want to be part of the adventure.
To be fair, the books and movies only focus on Gryffindor and to a degree Slytherin.
That's true.
Well, yeah. So those are the important people. Slytherin's the evil people. Gryffindor's the heroes.
So you're saying you're a
Hero.
hero?
Everything go to hell around you, just going like, thank God that's not us.
Hey. What was I doing? Oh, scheme. Wait, hold on. We got a chat.
Oh, the universe thing.
Oh, yeah. Because it's not cool. You gotta actually something Apple can do. And this was from years ago when Siri first came out. And this is pretty funny because my wife isn't necessarily a practical joker, but she programmed into Siri on my phone to refer to me as fatty. So I was talking to it saying something, and then it said like, "Okay, fatty." It's like just out of the blue, like.
Siri got attitude all of a sudden.
So I thought that was pretty funny. All right. Use Racket. All right. Let's dump all this stuff. So homework today was do all three of these. All right. So duple, return a list containing n copies of X. So where n is the number of things, X is the things that we're duplicating. All right, so this is that pattern we actually looked at last class, where we start counting down n until it hits 0, building up a list. And our constructor for constructing a list is called cons. So we will define duple to be a lambda that takes in a n and an x. Then we'll ask the question, lambda. And we'll ask the question if equal n 0, then we're going to boil down to the empty string. Else we will cons. Now we want to get this element, the X element, onto, so whatever X is, so that's going to be the car of the cdr. Actually, no, it's not the car of the cdr because this is in the list. This is the parameter. So we actually already have X. So we'll cons whatever X is onto the duple of minus N1, passing X back in. So if we call duple 3,3, we get a list containing 3 3s. Duple 7, hee hee. We got a list containing 7 hee hees. Now, actually, this is that example that I told you last class that you get some weird naming convention stuff. So this guy, what it's saying is that -1- is a placeholder for this list. So the output is a list containing 7 of those guys. 7 placeholders. I think there is a language that you can do where it expands it out, but this is correct. It's just saying that this is a list containing 7 of whatever this variable is, and this variable is that dude right there.
I have a question.
Nope.
The Zoom screen seems like zoomed in and we can't see the output. I don't know if it's something on my end or yours, but I was just curious if it looks weird in class.
I don't know. Does it look weird in class?
See the output in class.
Anybody else on Zoom? Or is he
Yeah,
watching?
it's like zoomed in, like you said. We just can't see the output.
All right, let me ninja something. I bet you it was because I shared my screen maybe before I put the adapter in. Can you see it better now?
That's better. Thank you.
All
Yeah,
right,
that's
yeah,
good.
that was the problem. I must have shared the screen when I first joined Zoom and then plugged the flippy thing into my computer. All right, I gotta take my medicine. Yeah, I have a prescription for it. Wrote it myself. Huh? Well, I'm a doctor. I can write that crap. I even tried to fill it at the pharmacy so insurance would cover it. I did it.
You, okay, you look for your opinion or whatever.
Huh?
So you actually get prescribed like coffee.
I doubt it. Well, actually, maybe. I doubt insurance would cover it, but some people do use coffee for alternative purposes. My dad did that for a while. We nicknamed him Sanka. If you don't know what I'm talking about, you can go and Google that or something. It's some homeopathic uses of coffee, something along those lines. All right, questions about this one? Go ahead.
So I found out that when you are displayed before the people, it shows the correct output. Why isn't that? Why does it show it?
What do you mean? If you call display here?
Yeah.
So if you say display the results of this guy, because display is a function that puts something on the screen. I'm guessing it probably put a little box around it. So it probably expands that out. Oh, yeah, just see it's in purple. First of all, I think they used to have a little box around it for display, but display goes through a different pattern and it expands it out. But you wouldn't want to get used to using this for your final output. It's fine if you like the way that looks better. But if you start including displays in your code here, things aren't going to work out the way you want it to work. Yeah, display is purely an output thing where we're actually just allowing the interpreter to do its thing and boil down to values. And then this guy just happens to give us a window into whatever the values that were boiled down. But that is as a good trick, if you left that display off and you got all those -1 things and you're like, okay, is this right? Looks like you can throw display out in front of it and it'll expand it out. And then I'm guessing there's probably one of the languages that'll do it too. If you go up here and do select, choose language, one of the languages probably will not do the variable substitution thing and But in a couple of weeks, this will be the least of your worries. So how did the assignment go?
Once I figured out the replacement thing,
How much time do we spend on it? I warned you, right? I said it's gonna be.
I got to a certain point, I'm just like,
You gave up and switched over to the Harry Potter marathon?
I don't
No,
want Harry Potter. I didn't like Harry Potter.
well, it was a weekend poorly spent. I watched the sci-fi anthology before that on Prime Video, and that was really good, but it was weird. Like each episode was like another weird thing. The first one dealt with like kind of in a future world where they have some kind of VR like little thing where you go into take a vacation from your life, but in the vacation it's kind of like in today's world there's a VR headset to take a vacation from your life. Oh man, and then the person gets confused on what's real. It was pretty good. Go ahead. That's fine. When I get like math homework or something. Just a random homework assignment from what, 300? Or is this like like an English assignment or anything? Oh, well, I would have thought it was funny. I would have read that. But then I would ask you what Dr. Manoj gave you. Actually, isn't there's a second philosophy prof now, right?
For CS department.
No. For I mean,
Oh, there's a-
our 410 class no, there's only
Is it Dr. Close or Dr.
they were all in the philosophy department or just teach classes of philosophy. Oh, interesting. Because for years and years and years, Dr. Manoj was it. All right, next one. Oh, go ahead.
Is there a website with like documentation for this that's really helpful?
Probably if you Google scheme documentation.
Okay, 'cause a lot of those are kind of scary.
Well, it's supposed to be scary looking at scheme.
It's not very modern looking documentation.
Well, yeah, because scheme is a superset of Lisp, and Lisp has been out for, I think, before the computer. But yeah, there should be some documentation out there, but I'm giving you everything in here that you're going to need to solve the assignments. So, you know, this assignment should have been solved with those, what, 6 or 7 functions that we talked about in class. Every one of them should have, you know, just like any of my classes, right? I'm going to give you the tools in your toolbox that you'll need to solve the assignments. And my expectation is you'll solve them with those tools. And I'm going to show you an example of a cool thing here in a few minutes. But I'm going to encourage you not to use it because it'll take some time to wrap your mind around it. And you'll start looking for answers using this function. But all right, next one, invert. And notice these are just 1-star questions. They get up to 3 stars. Yeah, 3 stars involves time travel. It's funny. So, all right, so invert, where the list is a list of 2 lists. So lengths of 2. Return a list with each 2 lists reversed. Oh, this is a good one that you could have, like, you can use this function for, but we'll write it normally first. So this guy invert takes in a list containing a bunch of 2 lists, and we want to take each of those 2 lists and reverse them. Now, actually, it's going to follow almost the identical pattern to what we just did, except instead of counting down, we're just going to be reducing the list. So it's called invert. So we'll define invert to be a lambda that's going to take a list as a parameter. We'll ask the question if null list, that's true, boil down to the empty list. Otherwise, we're going to cons. Now, what we want to do is we want to take the car of list, reverse the elements, and then pass it on to call invert again with the rest of those elements. So we're going to we'll create a list out of the car of LST and the counter of the car of LST. So the car is the first element of the list. So the car of the car would be the first element of the first element of the list. The car of the cooter of the first element of the list would be the second element in that two list. Oh, we're supposed to reverse them. That's right. This would duplicate the list that we had. That guy. So this will reverse the list. And we're going to cons that onto invert on the cooter of LST. So now we can call invert on, what's that, like an A1, B1, C1, something like that. And it should reverse all those dudes. 1A, 1B, 1C. All right. Cons constructs a list. So if I say cons here, and I want to cons an A onto the empty list, the second parameter of cons must be a list. So this is going to construct a list. That's what cons does. Cons builds lists. It constructs lists. So I'm going to cons this element onto this list, which will produce the list A. And I can string conses together. So I'm going to cons A onto the cons of B, onto the cons of C, onto the empty list. And you break this down, this first thing right here, this guy, that will produce the list containing C, to which I will cons a B onto, which will produce the list containing BC, which I will cons A onto, which will produce the list containing ABC. That makes sense online? So it constructs a list. That's what that dude does. So don't overthink it. It doesn't do anything more than that. First parameter can be any kind of element, anything that scheme supports, but the second parameter must be a list. And remember the antithesis, sort of kind of the antithesis, I guess, we looked at last time was the append function, which allows you to glue two lists together. So if I said, for example, if I said cons A, B, C onto D, E, F, this is going to give me the list containing as a first element, the list A, B, C, and then D, E, F is the rest of the elements. So here's a list whose first element is that, second element is that, third element is that, fourth element is that. As opposed to if I did the same thing, but I used append. So append takes two lists as parameters and it glues these guys together, concatenates them together. So now I'll have the single list containing the elements A, B, C, D, E, F. That makes sense? All right, so let me show you a another version of invert using another function. So we'll call this guy define, we'll call this guy invert2. This will be a lambda that takes in a list as a parameter. And what we're going to do is we're going to map the lambda that takes in X and we produce a list out of the catter of X and the car of X over the list. So there's that same output. All right, so now this should scare the crap out of you. So what am I doing here? So map is a function that applies a function across the contents of a list. Now, the function it's applying across the contents of a list has to be a function that takes one parameter. So if we look at this, here's my list. I have this function of applying. This function takes one parameter. The first time it gets called, this is X. This is X. This is X. So it is mapping this function across this entire list, producing a new list, which is the result of applying this function to each individual element of that list. So what does this function do? It takes a single parameter and it assumes that parameter is a two list, and it creates a list that is the reverse of those guys. Go ahead. Well, I mean, yes, it is. I guess, what do you mean by, is it like chaining functions together? Obviously, we're calling a function inside of a function, but really what this proves is that function, something we said, I don't know, last class before, something like that, is that a function is just the data type in Scheme, no more. So I'm passing two things to this function, a function and a list. Yeah, so I mean, I'm calling map. Map takes two parameters. It expects that first parameter to be a function that takes one parameter, and it expects the second parameter to be a list of things that it can apply that function to. But it does need to be compatible. So if I call invert 2 on the list A, B, C, we're going to die here, right? Because I start trying to take the catter of an A, that's not going to work out so hot. If I try to take the car of an A, it's not going to work out so hot. So we're going to get it screaming at us there. It was given an A, but we tried to take the catter of A, which is, you know, unauthorized surgery. Go ahead.
Is there like a way, like, you know, like a type of track? Is there a way to do that to check to see?
Probably. Yeah, there's probably the equivalent of that in Scheme. But you won't have to use that in here. You know, we might do some error checking just from the perspective. You might say, you know, if whatever you're about to apply to is a list. So if I was going to do this, I could say something like, you know, if list X, then do this crap. Otherwise, I could say just boil down to LOL or something like that. In my if. Oh, I'm missing an extra ninja. That's the end of my lambda. So there's my, didn't scream at us the second time because it said, oh, the parameter is not a list, so I'm not going to try to do catters and cars from it. I'll just boil down to LOL for no good reason. All right, so what I'll say here is I have now officially introduced you to a function called map. Very powerful function, but you never, ever, ever, ever have to use it. So I encourage you to maybe consider using it on occasion, because there are some examples where map is like the perfect tool, right? But don't get ahead of yourself here, because you're already probably frustrated with scheme and getting used to using things. So now if you have to think about a whole new pattern of, oh, well, what if I just apply it, I function across a list, that might just be the thing that pushes you over the edge. So this isn't something that you will need to use on any assignment. It just might make certain things a little bit easier. But the reality is you have to decide, is that actually easier than this? It is less parentheses, but is it actually easier? Many of you might feel a little uncomfortable right now passing a unnamed function in as a parameter to a function. All right, questions about invert 2 or invert any of those dudes? Last one, down wraps parentheses around each top level element of list. All right, so for example, this is a great one for map. So down, I'll think about how to do it here in a second, but down, if we're just wrapping parentheses around each of these guys inside of list, when you write down, get rid of this call here, define down to be a lambda, ninja, nailed it. It takes a list as a parameter and map list across list. That's down. So if I call down on A, B, C, I'm really struggling with the keyboard here. We'll get the list A, the list B, the list C. So built into scheme, there is a function called list. I am mapping the function called list across all the elements of my parameter that was a list, making each individual element wrapped in a list. All right. So that one was kind of built for the list function, or for the map function rather. But let's write it the way that we would have, I'll call this guy down 2. And again, I'm officially encouraging you not to try to use map right now. Eventually you'll jump into the deep end and start trying to do that. But I think for a lot of you, it's going to be frustrating if you're always trying to fit map into every single question. That's why I'm telling you, you never, ever have to use map. You can accomplish every single problem without ever using the map function. Because every now and then the moons align like this one, and map just makes it trivial. All right, so what we should start seeing here is that we have a pattern that's emerging. So down is going to take a list as a parameter. So whenever we take a list as a parameter and we're returning a new list, we're boiling down to a new list, we're probably going to follow that pattern where we're asking that question. Are we left with the empty list? If it's the empty list, that's the end of our recursion. So if null LST, boil down to the empty list. Otherwise, we will cons the list version of car LST onto down of cooter LST. Okay, and this is the same pattern we saw a few minutes ago. If whatever our parameter is currently the empty list, boil down to the empty list. Why? Because the last parameter of cons must be a list. We talked about cons. Cons takes 2 parameters, something and a list. So if you have a whole bunch of cons, there's the cons onto the cons, onto the cons, onto the cons, somewhere at the very, 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 very end, There's got to be a list. That's the list that ends our recursion. So if I've run out of elements to do stuff to, just boil down to the empty list to finish my ultimate cons. Otherwise, we're going to con something. What's that something? The list version of the car of our list. Or if you don't like using list here, you can say the cons of that guy onto the empty list. That's equivalent to saying the list version of the car of the list. So we're going to cons the list version of the first element onto whatever down returns for the rest of the list. That's our recursive calls. Make some sense? All right, now I'm guessing most of you probably prefer that syntax using the list function. I think the list function seems to be a little cleaner than consing something onto the empty list, even though the list is probably written in terms of that. All right, so that was everything for the homework. Okie dokie. So what I can do here is I'll just paste that into the 470 channel on Slack, just in case I didn't, because we might have a couple of students who haven't. If you're not in our Slack channel, if you go to cwcs.slack.com and then create an account with your CUW email. If you're at CUAA, try to do it. If it doesn't let you in, message me and I'll send you a link that'll let you in. But once you join the Slack channel, what you're put into by default is just the general channel. So you'll have to go down here to channels, and then hit this little plus sign, and then you can browse the channels and find CSC470. So that's where you're going to find the code I'm about to paste. So that's the shortcuts. No. Where's my embed code thingy? Oh, this guy? Ah, this guy? Ha ha! Nailed it. Wait, I have to. Oh, code block. Ninja. All right. So there's all that stuff. All right. So easy peasy. So if you spent any more than 10 minutes in this homework, you're behind the. I would say if you spent more than 3 hours on the homework, then you're going to want to practice with Scheme a bunch. All right. Let's see. All right, so we've talked about predicates here. We're introducing one more predicate. So we've already seen null. Null returns true if the parameter is the empty list, false otherwise. List returns true if the thing we're looking at is a list. So for example, if I call the list predicate, notice that naming conventions for predicates that are built in typically have little question marks on the end of them. So list on just A is going to return false. List on the list A is going to return true. This lets us know whether the thing we're passing in is a list or not. Make sense? Similarly, the other predicate, the one that came after that in the slides, was the predicate called symbol. Go ahead.
Can you remind me what the little apostrophe is?
This guy is called the quote. It says, because remember in Scheme, whenever we have a list, if we don't have that quote there, whatever the first element of that list is going to be treated as a function name. This is the function called A applied to no parameters. And it's going to scream at us saying A is not a function, as opposed to this guy, which says this is a list literal. Do not try to treat the first guy as a function name. So if you're passing around lists and you don't expect Scheme to execute the contents of the list, put a quote in front of it. All right, so the other guy here was symbol. So if I pass it the list A, this is kind of the inverse of my last example. The list A is not a symbol, so it's going to be false. But just A will be true. That's a symbol. All right, so we've added another predicate, maybe two predicates. I don't remember if we had talked about list before, but now we have 3 total predicates that we can operate with. Is the list I'm looking at the empty list? Is the thing I'm looking at a list, or is the thing I'm looking at a symbol? Or is the thing I'm looking at not a list or not a symbol? If we were going to throw something else in there, we do have the not keyword. So I could say not list A. So is list of A true? Yes, it is. The list A is a list. Not that will be false. So this is our not function, which just takes a Boolean and flips it. If whatever was passed in is a true, it'll boil down to a false. If whatever was passed in was a false, it'll boil down to a true. So there's a false being passed in, and this will become a true. All right, questions about that? All right, so a couple more tools for our toolbox. All right, so, oh man, look, we got a 2-star one in here. It's gonna be terrible. All right, so let's look at this next one. So we have a function called swapper. Returns a list the same as our S list. So we're taking 3 parameters, S1, S2, and S3. Returns a list that is the same as the 3rd parameter, but with all occurrences of S1 replaced by S2, and all occurrences of S2 replaced by S1. So we're basically doing a search and replace in S list, replacing S1 with S2 and all S2s with S1s, and leaving everything else alone. Okay, so pretty similar thing. We are building a list, right? So we're probably going to have that pattern where we're calling cons on possibly we're going to do something to the first element of the list. We're either going to swap it with, if it's equal to S1, we'll swap it with S2. If it's equal to S2, we'll swap it with S1. If it's neither of those, we'll just leave it as is. Whatever it was, we'll just keep it, right? So we'll do something, including potentially nothing, to the car of our list, and then we'll call swapper on the rest of the list and keep doing that until we finally end up with the empty list. That same pattern again. That makes sense? All right, so go ahead and take about 5 minutes and try to make an attempt at swapper here in terms of the patterns we looked at today. I literally just spoke the solution. All right, so we're going to keep consing onto the list one of three things. We'll cons an S2 onto the list if the thing we're looking at is an S1. We'll cons an S1 onto the list if the thing we're looking at is an S2. Otherwise, we'll just cons the car of the list onto all three of those. It'll be calling swapper on the same S1, the same S2, and the cooter of S list. Keep doing that until we run out of stuff to ask questions about. Oh, lost my game. Well, that's crap. Your homework just got harder. And I won in a tiebreaker. So good. All right, let's take a look at this. Exciting. All right, so we're looking at swapper. I'll get rid of all this crap since I already pasted that. So we'll define swapper to be a lambda that takes in a S1 and S2 and what do they call it? S list, something like that. All right. And we're going to ask that question. We're going to say if null S list boil down to the empty list. Same pattern we've seen already. Otherwise, the list must have something in it. So we're going to look at the car of that list and make some decisions about what we should do with it. We'll do this inside of a cond because we're really going to be asking 3 questions. If it's one thing, do something. If it's another thing, do something else. Otherwise, do the default. All right, so we'll say cond if equals car of S list and S1. If those are the same value, then what are we going to do? We're going to cons S2 onto swapper S1, S2, coder of S list. If equal car S list S2, then we'll cons S1 onto swapper S1, S2, coder of S list. Else, we'll cons the car of S list onto whatever swapper S1, S2, coder of S list returns. So we'll call swapper. Let's use one of their examples. Let's see, A, D, A, B, C, D. All right, so all occurrences of A should be a D, all occurrences of D should be an A, so this should be a D, B, C, A. Oh, I technically didn't show you something you needed to have. The equal sign, single equal sign, only does numeric comparisons. We need to compare a char, a character against something. So we have another equivalent operator that operates on symbols, and that's EQ. So there's our DBCA. All right, and then we actually have 2 more equivalent operators, EQV and then equal. I typically will say equal detects bone structure. As we get to them, we'll see examples of those guys. All right, the pattern is the same. Even though the code is getting a little bit longer, we're actually looking at the identical pattern, right? If our list that was passed in has run out of stuff to process, return the empty list. Because this is going to finish off a series of conses. Otherwise, let's ask a question. So we're using a cond instead of a if, because we're really asking 3 things, right? We could do this with ifs. We could just chain some ifs together, but it would be a little messier. So the first thing we're asking is this. If the first element in S list is S1, then we're going to do a swap. So we'll cons S2 onto whatever swapper returns for the rest of the list. If the first element we're looking at is S2, then we'll do a swap. We'll cons S1 onto whatever swapper returns for the rest of the list. Now, do remember that swapper expects 3 parameters: a symbol, and a list. So I'm going to keep passing that same S1, S2 in each time I call it. Those guys are not changing. The only thing that's changing is the list that I'm operating on. All right, questions on that? All right, so this is actually kind of a good one. Let's come and do the 2-star one next, after this next one. So let's do this 1-star one first. This actually could be a 1-star. It's not very difficult, but let's look at this 1-star. Count occurrences is going to take a symbol as well as a S list, and it's going to return the number of occurrences of S in the S list. So now this becomes a little bit interesting. So here's an example here. Our list of symbols contains other lists of symbols. So an S list is either an empty list or it's a list containing a symbol followed by an S list, or it's a list containing an S list followed by an S list. That means anytime we see a list in here, we need to process it through our count occurrences, which knows how to operate on S lists. All right, so frankly, these maybe should be switched for which one's a 2-star and which one's a 1-star. So let's write count occurrences, and we'll write this together. It's not really any more difficult. It's just one more layer of recursive thinking. All right, because as we go through this entire thing here is an S list. And count occurrences, as we're going to write it, operates on S lists, right? So whenever we see an S list, we should call count occurrences. Since this is an S list, we'll call count occurrences. This is just a symbol, so we'll just check to see if it matches what we're looking for. This is a list containing an S list and a symbol. So we got to keep breaking it down, calling count occurrences whenever we run into something that is a list. All right. But ultimately, our job here is to return a sum, a number that is the number of times the element, in this case, X, or by the generic S, appears anywhere in this S list. All right. The worst part of this is going to be calling or spelling count occurrences, not a strength. All right, so we'll define count occurrences. That can't be right. 2 R's and an E. There'd be an S in there. Is that right? It looks right. I'm going to copy that so I don't have to do that again. This guy will be a lambda that takes in an S and an S list. All right. So now we're going to be asking some questions. If we're looking at a symbol, we want to say, well, if the car of this guy is a symbol, we're going to say, does it match the thing we were looking for? If yes, we should count as 1. And we're going to add that 1 to whatever S count occurrences returns for the rest of the list. So in this case, the new pattern is instead of consing a bunch of stuff together, we're actually counting keeping a running total of counts. So we'll have a cond. Our cond is going to say, if we're looking at the empty list, if I've run out of stuff to check, what do you think my default value should be? We're no longer finishing a list, finishing a cons. Now we're finishing a sum. So how can we stop finishing a sum without changing our ultimate answer? Look at a 0, right? Boil down to a 0. That's not going to break our sum, right? So if I've run out of things to check, my stop point there will be a 0, which will be compatible with my addition function that I'm going to be calling over and over and over again. All right. If I'm not looking at a null, then I know that I at least have one element. That means I can legally call the car of the S list. So I'm going to ask the question, if symbol car S list, if that guy is a symbol, actually, you know what? Let's ask the list version of this first. That way we can use the symbol as the else. You can go either way. It's just going to keep us from asking one extra question. If the car of S list is a list, then we know what we need to do is we need to call count occurrences on the first element, which is an S list, along with the rest of the elements. So I'm going to return the sum of, I'll keep it down a line here, the sum of count occurrences on the car of S list, which we know to be a list, along with count occurrences on the cooter of S list. Add those two things together. Else, I must be dealing with a sum or a symbol. So if I'm dealing with a symbol, then I can ask the question, if equivalent car of S list and S, if those guys are equivalent to each other, then I want to add one to count occurrences cooter S list. Else, I can just call count occurrences cooter S list, or if we like the look of it better, just for the pattern, we can say we're going to add 0 to count occurrences cooter S list. This guy said, I found a match, so I'll count it. This guy said, I didn't find a match, so I won't count it. I'll add a 0. But in actuality, we didn't need to add a 0. We could have just called count occurrences another time. There was no number that had to boil down here. All right, so let me do this on one of our, so X, and the hardest thing on some of these things is making the input. And actually that's a true statement. So make sure that you create proper inputs. It's going to get harder and harder as we start having actual language structure coming into our parsers, where you might have code that works, but you fed it bad syntax. You invented the programming language that we're going to be writing in here, but you actually write bad syntax in the language that you wrote. So now your parser doesn't work for it. But it's not because the parser is broken. It's because you didn't write appropriate code for the language you invented. It's going to happen. Okay. But anytime it happens in class, I did it on purpose. So let's see, list FX. then y, xz, x, two arguments. Oh, whenever I call count occurrences, I need to make sure I pass it the argument. So every single time I call count occurrences, it requires me to pass it two parameters. I'm changing my S list, but S is always going to remain the same. Did I get them all? There we go. So there's our three. So I'm looking for X in this S list. So the first thing it's going to do is it's going to say, is this the empty list? It's not. So then it's going to look at the car. Is this a list? It is. So what am I going to do? I'm going to return the sum of calling count occurrences on the car, that list, along with I'm going to add that to calling count occurrences on the rest of this dude. That's what we did right there. So we have two separate recursive calls here. The first time we're calling count occurrences on the first element. The second time we're calling count occurrences on the rest of the elements, not including the first element. And it doesn't matter that this guy here has to wait for this guy to complete. We're eventually going to get a number out of this, and it's going to be the sum of the rest of this stuff. That makes sense? So then that first recursive call, when we're looking at that list, is it the empty list? No. Is it a list? I'm actually looking at this here. Is the car of this guy a list? It's not. So it must be a symbol. If that symbol is equal to the thing I was searching for, is an F the same thing as an X? It's not. So I will add 0 onto count occurrences of the list containing an X. The next time through, is it a list or is it the empty list? Yes. Is it a list? No, X is not a list. So it must be a symbol. Is the symbol X equal to the symbol I was looking for? Yes, it is. So I'll add 1 onto count occurrences of S and the footer of the list. So now I'm passing it the empty list. Is it the empty list? Yes. Boil down to a 0. 1 plus 0 is 1. So the result of calling count occurrences on this first part here gave us the number 1. Then calling count occurrences on this stuff here, we got a 0 from that guy. Then we had a list containing a list, blah, 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 blah. We found this X, we found this X, that gave us our 3. All right, that makes some sense. All right. Last one, list set. Returns a list like LST, except the nth element using 0-based indexing should be an X. So whatever LST originally was, we want to keep it that way. But as soon as we get to bucket N, we want to swap in an X rather than what used to be there. What it was called, list set, like that. All right, and this guy is going to be a lambda that's going to take in a list. N was the next one. Okay, now we are building a list, right? So we know we're going to have that pattern of searching for when we finally run out of things to look at. Okay. So we're going to say, I'll do this in a con since I think we have 3 questions to ask. So we'll say null LST. If that's true, we'll boil down to the empty string. All right. Otherwise, we now have a numeric thing going on here too, right? We're going to be counting down N. All right. So we're going to ask, is N equal to 0? If N is equal to 0, what do? we cons an X, whatever this variable holds, the value of X, onto list set minus N1 have to put of our list first. Put of our list minus N1 and whatever X was. That's if I was looking at a 0. So now N just went to -1, -2, -3. We'll never hit the value again. Else we'll cons the car of list onto list set of the coder of the list minus N1 and X. So 2 of our patterns both making an appearance inside of a single thing. We're building up a list, so we need to search for the empty list that finally ends our recursive calls. We're also counting down, so we know that single element that needs to be swapped. So that's that same thing we saw in duple, right? Where we counted down. And we do our swap in here, where we cons an X instead of consing the car of the list on. Otherwise, we just kind of go with the motion, keep building our list up identically to how it was before, decrementing in as we go through. So let's see, A, B, C, D, 2, 1, 2. We'll say bucket 2. So this is going to replace bucket 2. So this is 0, 1, 2, the C with the list 1, 2. A, B, and instead of the C, we have the list 1, 2, and then our D. Right, so there's list set. I guess the reason that's a 2 star is because we technically have 2 patterns that are making an appearance. Not that the logic was, I mean, I would maybe say the logic of this one is a little bit more difficult. But because we have 2 patterns that make an appearance here, it's worse, I guess. All right, so I'll copy all that. We'll put it, it's this one. All right, so I put those examples into Slack. And then let's see what we have for homework. Oh my gosh, 3 2 stars. It's going to be a thing of nightmares. Let's see. Product SOS. Oh my gosh, that one's horrific. List of those elements. The second one's easy. The third one's not bad either. Only the first one will haunt you. All right, so homework for Thursday is was it slide 39, homework 2. I'll upload it onto Blackboard. So these 3 2-star questions, if you spend more than 25 hours on the assignment, I would probably just give up and write some kind of funny joke or something to submit. You'll probably earn more points. Questions, comments, concerns, bribes. All right, I'll see everybody on Thursday. Front Row Club at Chapel here in 10 minutes.